2021, Paper 1. Question 1. What do the quantities of length, temperature, and mass all have? So for length, we know that the units is meter, temperature, K for Kelvin, mass, kg. And you know all of them are scalar quantities, which means they have a magnitude and a unit. If you have a magnitude, a direction, and your unit, it is a vector quantity. And some examples are displacement, unit is m, weight, because it's a force, the unit is Newton. Question 2. The speed time graph for a runner during the first 10 seconds of the race, t, is shown. Which statement about the motion of the runner during this 10 seconds period is correct? So as we know, the area under a speed time graph is equals to distance. Okay. So during this period t of 10 seconds, we can find the total distance equals to, first a triangle, half times 5 times 8 plus 5 times 8. Here is only 5 seconds. You get a distance of 60 meters. To find average speed, formula for average speed is equals to total distance over total time taken, which is equals to 60 divided by 10, 6.0 meter per second. Question 3. A car accelerates along a straight road, then moves at a constant speed. Finally, the car slows down to a rest. When are the forces on the car balanced? So when it's balanced, is when F net, resultant force, is 0. And that's when acceleration is 0 meter per second per second. And that's when it's constant speed as well as at rest. Question 4. A moving bus suddenly brakes very suddenly. The standing passengers fall forward inside the bus. So they fall forward because of Newton's first law, which is the law of inertia. So an object, which is the passenger now, in motion, remains in motion. And that's why the passengers have inertia and the passengers fall forward. Question 5. The table shows the density of various substances and its density. Which statement is correct? So let's go to the triangle MVP, mass, volume, density. We know that density is equals to mass over volume. In statement 1, 1 centimeter cube, which is the volume of mercury, has a greater mass than 1 centimeter cube of any other substance. And that's correct because for the same volume, using the formula rho equals to m over v, mercury will have the largest density. Since mercury has the largest density, it will have the largest or the greatest mass. Question 6. A car mechanic loosen a nut by turning the spanner anti-clockwise. This direction is anti-clockwise. Which arrow shows the position and the direction of the smallest force that loosened the nut? So as we know the formula, moment equals to force times perpendicular distance. If I want the smallest force, I will need to have the largest perpendicular distance. So for this type of question, first you find where the pivot is, draw the triangle, pivot, and this will be the largest perpendicular distance. And since you want it to be an anti-clockwise moment, the force must be in this direction. Question 7. The handle on the door is pulled by a force F in the direction shown. To open the door, F produces a moment of 0.30 Newton per meter about the hinge. What is the value of F? So first, in moments question, we find the pivot. So the pivot here is the hinge. It's where the hinge is. Draw the triangle. Second, we find the line of action of the force. So since the force is here, I draw a line of action. Make sure it's dotted. So this is the line of action of the force. And then we will apply the moments. M equals to F times perpendicular D. So where the pivot is, the hinge, to the line of action, this will be your perpendicular distance. So moment was given as 0.30 equals to the force that we're trying to find times perpendicular distance 0.50. F is calculated to be 0.60 Newton. Question 8. What is the formula for kinetic energy of a mass m traveling with velocity v? Formula is simply Ke equals to half mv squared. If they ask you to find gravitational potential energy, GPE, the formula is mgh. Okay, question 9. A crane lifts a weight. Okay, so a weight is force or small w through a height h, which is displacement, in a time t. The job requires the crane to work at greatest power. P question mark. So we know the first formula, P work done over time. It's equation 1. Work done equals to force times displacement, small s. Second equation, we can sub the work done in. We get P equals to F times S over T. F is given as small w. S was given as the height over the time T. So this is for P, power. So if I want for the largest P, I will want my W to increase, my H to increase, or my time to decrease. And we calculate for the option D, P equals to 2W times 2H over 2T. You actually get 2WH over T. And that's the largest combination of all four. Question 10. Under certain conditions, a gas can turn directly into solid, which shows the change in intermolecular distance and intermolecular forces as this happens. So for gas, if I were to draw a gas, the particles are far apart. So the intermolecular distance is far. For liquid, they are not in the orderly, but they are very close. So intermolecular distance is small. For solid, they are arranged in an orderly arrangement. So decreases. As it becomes from gas to solid, okay, intermolecular forces increase. Question 11. 3 blocks. P, Q, and R are the same size and made from the same material. They are coated and set up in the diagram shown below. P, Q, and R emits thermal energy. The table shows statement about amount of thermal energy emitted per second by the block. Which row is correct? So as we know, a white and smooth surface is a bad emitter and bad absorber. A black and rough surface is a good emitter, also a good absorber, okay, of infrared radiation. Low surface temperature is also a bad emitter and bad absorber of infrared radiation. So from here, we know that the worst is actually P, since it's white, okay, followed by R, because R compared to Q has a lower surface temperature, and the best emitter is Q. So in this order. Statement 1, P less than Q, R less than Q. Question 12. A sample of liquid at a temperature of 80 degrees cools down and solidifies. The graph shows the temperature against time as the sample cools. So it says that this will be liquid, here will be liquid plus solid, and here will be solid. So this is actually the region of freezing. And how long does the process of solidification, which is freezing, take? It's actually where the region where the temperature is constant. There is no change in temperature when there's a change in state. And that is 3 minutes. Question 13. A stone is dropped into a pond. The ripples produced are circular and spread out as shown. So what are these ripples? These ripples are actually the crest of the wave. The trough of the wave is underwater, so you can't see. So actually, when you connect all the crests together, they are a wavefront. Question 14. Which row describes the property of EM wave, electromagnetic wave? So we know EM wave are transverse wave. All EM wave are transverse wave. They do not require a medium to travel in, and in vacuum, they travel at a speed of light c, which is 3.0 times 10 to the power of 8 meter per second. So in this question, take note they use cm per second, so you need to convert to cm per second times 10 power of 10 cm per second. So be careful. Question 15. A battery-operated bell is surrounded by a box with double walls. The bell is ringing, but no sound is at all is heard outside the box. Because why? Sound is a longitudinal wave. And longitudinal wave consists of compression and rarefactions. And it requires a medium. So this one is likely to be a vacuum. So sound wave cannot travel in vacuum. Question 16. The arrows R and S shows 2 directions in a circuit. What are the directions of the electron flow and the conventional current flow in this circuit? As we know, let me draw it out. The longer end is the positive terminal, shorter end is the negative terminal. Conventional current flows from positive to the negative, so I this way. Electron flow flows from the negative terminal. So here, positive, negative, I. Downwards should be electron flow. Okay, question 17. A length of wire has a resistance of 24 ohms. So you can give it R. The length of the wire is 30 centimeter and it has a cross-sectional area of 4.0 mm squared, which a wire made of the same material, so rho is the same, has a resistance of 48 ohms. This is double this, so now we can call it R2, R1. 30 centimeter is L1, 4.0 mm A1. We know the formula, R equals to rho L over A. For R1, we have rho L1 A1. So since R2 is actually 2 times 24, we can actually see as 48 ohms, which is 2 times 24, which is 2 times of R1. Okay, we can sub it back into the equation. R2 should be equals to, since same material, rho L1 over half A1. Okay, or another combination is rho 2L1, is twice as long, over A1, will give you the same resistance as R1. So which means the wire can either have twice the diameter, half the diameter or twice the length to get a high resistance of 2 times. Question 18. The diagram shows a circuit. Which pair of statements shows the relationship between the readings and the meters? One look, you should know that the circuit is a series circuit, which means the current here, I2, the current here going to the emitter I3, the current here going to the emitter I4, current going inside here, I1, are all the same here because they are in series. V1 is actually the EMF where the batteries are. So it's actually the EMF. And since in the series circuit, EMF should be equals to all the individual components, individual PDs, V2 plus V3 plus V4, because it's a series circuit. Question 19. An electric shower has a power rating of 10 kilowatts. P runs for 5 minutes. T, each time the shower is used. The cost of electricity is 30 cents per kilowatt hours. Take note, per kilowatt hours. So this is unit cost. So since it's per kilowatt hours, we need to convert this 5 minutes, T, 5 minutes, into hours, 5 over 60 hours. Okay, first equation we use P equals to energy over time. Second equation, cost equals to energy multiplied by unit cost. Here we can submit from equation 1 to equation 2. E is actually PT times unit cost. P is 10 kilowatt hours, but since this unit is in kilowatt hours, we can keep it as 10 times 5 over 60 because it's in hours times the unit cost 0.30, 30 cents. And since we use it for 30 days, 300 days times 300. So your answer should have been $75. Question 20. The cable connecting a hairdryer to the mains contains only a live and a neutral wire. So there is no earth wire. Why? Because the hairdryer is doubly insulated. This is the symbol for double insulation. Okay, if the outer case is made of metal, it needs to be connected to the earth wire. And this is the end of paper 1.